Ion exchange. The phenomena of ion exchange was first reported by two British agricultural chemists in 1850 who proved that soil can remove potassium or ammonium salts from water with release of an equivalent amount of the calcium salt. After the work of Gans in 1913, natural and synthetic inorganic cation exchangers were used for softening hard water. Modern ion exchange resins were first used in 1935 by Adams and Holmes. These resins consisted of three-dimensional network of polymeric chains cross-linked with short chains containing ionizable functional groups. The major work on chromatographic separations by the use of ion exchange resins has been mainly derived from the studies carried out in connection with the work on atomic energy in the United States of America. Ion exchange may be defined as a reversible reaction in which free mobile ions of a solid called ion exchanger are exchanged for different ions of similar charge present in the solution. Ion exchangers consist of an insoluble organic polymer into which a charged group is introduced in some suitable manner. The backbone of the ion exchanger is generally a styrene divinyl benzene copolymer. Copolymers of acrylic acid derivatives, divinyl benzene, are also used. For use with biological macromolecules, uh, charged groups are introduced into cellulose fibers. For a large period, cross-linked dextran, also known as Cefadex, was used as carrier material. The most common properties of all ion exchangers are as follows. They are almost insoluble in water and organic solvents such as benzene, carbon tetrachloride, ether, etc. They are complex in nature. In fact, they are polymeric. They have active or counter ions that will exchange reversibly with other ions in a surrounding solution without any substantial change in the material. Let us see the principle of the ion exchanger. The principal feature involving ion exchangers is the attraction between oppositely charged particles. Many biological materials, for example, amino acids and proteins, they have ionizable groups. And it is also a fact that they carry a net positive or net negative charge. And this can be utilized in separating mixtures of such compounds. The net charge exhibited by such compounds is dependent on their pKa value and on the pH of the solution in accordance with the Henderson-Hasselbalch equation. Ion exchange separations are mainly carried out in columns which are packed with an ion exchanger. There are two types of ion exchangers, namely cation ion exchangers and anion ion exchangers. Cation exchangers possess negatively charged groups which will attract positively charged molecules. These exchangers are also called as acidic ion exchange materials since their negative charges result from the proteolysis of acidic groups. Anion exchangers have positively charged groups which attract negatively charged molecules. The term basic ion exchange materials is also used to describe the anion exchangers since positive charge results from the association of protons with basic groups. The actual ion exchange mechanism is composed of 5 distinct steps. The first step is the diffusion of the ion to the exchanger surface. This occurs very quickly in homogeneous solution. The second step is the diffusion of the ion through the matrix structure of the exchanger to the exchange site. This step is dependent upon the degree of cross linkage of the exchanger and the concentration of the solution. This process is thought to be the step which controls the rate of the whole ion exchange process. The third step is the exchange of ions at the exchange site. This step is considered to occur instantaneously and is an equilibrium process. An example is shown in the following equation, where an exchanger which is represented by RSO3 minus combines with sodium ion, which is a counter ions. It forms N plus H3R dash, which is a charged molecule which is to be exchanged, and gives RSO3 minus plus NH3R dash with positive charge on the nitrogen atom, which is a bound molecular ion, and gives sodium, which is exchanged ion. Similarly, an expression for anion exchanger is also given. The more highly charged the molecule to be exchanged, the tighter it binds to the exchanger and the less readily it is displaced by other ions. Next step, and fourth step, is the diffusion of the exchanged ion through the exchanger to the surface. And the last step is the selective desorption by the eluent and diffusion of the molecule into the external solution. The selective desorption of the bound molecule is achieved by changes in pH or ionic concentration or by affinity elution, in which case an ion which has greater affinity for the exchanger than the bound molecule is introduced into the system.